Chapter 7, Chemical Reactions. Many times when a chemical reaction occurs, there is something that we can detect with our senses that indicates that a chemical reaction has occurred. Remember that if we're putting two substances together, we could have a physical change where things are just getting mixed, or we can have a chemical change in which old substances are destroyed and new substances are formed. A chemical reaction is a chemical change. Two different terms for the same idea. So, what are these observations that we have a chemical reaction occurring? The first is that a gas is produced. So here's an example. I don't know exactly what they dropped in there. It kind of looks like Rolaids or something, though, doesn't it? Plop, plop, fizz, fizz. Oh, those usually go to the bottom. I don't think that's Rolaids. Might be magnesium or zinc in acid. But do we see something happening? There's bubbling and fizzing. Why are there bubbles forming? There's a gas forming. Was the gas there before? No, the gas wasn't there before. So we're seeing something new. We can tell it's new because it's a gas and it bubbles out of the solution. So if you see bubbles forming or fizzing, that suggests, doesn't prove, but suggests that a chemical reaction is occurring. An insoluble solid is produced in a solution. So when we dissolve things like table salt or sugar in water, it forms what's called an aqueous solution. The substance is dissolved in water. If we take two solutions and mix them together, sometimes we see something like this occurring. So here we see that this solution was clear and colorless, and we're dropping another liquid into it that's clear and colorless. And now we've got two things actually occurring, but we see that there's an opaque area here, and there seems to be something that's settling onto the bottom. That's a solid. When something is dissolved in a liquid, you can't see its presence. You can see straight through the solution. Sometimes it adds a color, but it's still clear. Like Jell-O is clear, right? You can see through it if it's thin enough. Milk is not. Ice cream is not. You can't see through milk because it's got a lot of little particles kind of hanging around in it. So anytime we see a cloudiness or a milkiness when we mix two solutions, that lets us know that a solid has formed. If we allowed this solution to sit, all these particles would come and sit at the bottom because they're solids, and they'll slowly fall down to the bottom. It's a little bit like if you took some water from the river or from a lake and it's got sand and silt in it and it's all mixed up. You can't see through it, right? It's not clear. If you let it sit, though, the sand and even the silt and the other junk will eventually fall to the bottom. Okay, so if you get a solid formed that wasn't there before, that's evidence for a chemical reaction. A permanent color change. Here we've got the solid forming and a color change. There was nothing yellow there before, and now there's something yellow. That tells us that a chemical reaction has occurred. Sometimes we use things such as indicators that allow us to see that a reaction has occurred, even though we can't detect it with our eyes otherwise. Energy. Energy being given off or being absorbed is also evidence for a chemical reaction. Chemical reactions always involve some sort of energy change. Some of them are so small that they're not noticeable, but they all involve a chemical energy change. Heat and light are both forms of energy. And so in this example, I think that's probably potassium. I'm not positive. This is one of the alkali metals in water. And we see that there's a lot of heat given off. That doesn't make sense, does it? How do you see heat given off? If we were actually doing this, we would feel that heat is given off. And this is actually flame occurring. There's hydrogen gas being given off, and so much energy that the hydrogen spontaneously ignites. And so you put the solid into some water, and you see this burning cloud above the water. You're like, whoa, something is going on there, right? Chemical reaction. There are two kinds of heat-related reactions, exothermic and endothermic. And these are terms that you need to be familiar with. So we've got prefixes here, exo and endo. There's an exit sign. What does exit mean? To exit, yeah. When I exit the room, am I going out or coming in? You're going out, right? Exit is to go out. Thermic refers to heat energy. Exothermic means that heat energy is leaving the chemical reaction. It's exiting the chemical reaction. This is an example of an exothermic reaction because it's giving off heat. Endo is the opposite. It's like into. Endothermic means that energy is going into the reaction. Have you seen those instant cold packs you can get? You can get them, to have like on the sidelines of a football game or something. If you don't have ice available, somebody's spraying something, and there's this little thing inside, and you break the seal, and this plastic pouch gets cold. It's kind of freaky if you really start to think about it. They also have hot packs, right? Warm packs and like hand warmers and stuff if you're skiing, and you mix them together, and they get warm all by themselves. Those are chemical reactions occurring. The one that gets cold because it's pulling energy, heat energy from the surroundings. And so you touch it with your hand and it's pulling heat out of your hand. The ones that get hot are exothermic. The reaction is giving off energy. Can you think of an example of a reaction that gives off light that you might encounter in everyday life? A glow stick or a flame. You light a candle, you light a gas grill, and you have this flame and it's giving off light. It's also giving off energy. That's an exothermic reaction. A glow stick. My kids love those things. We always buy a bunch of them at the dollar store before we go watch the fireworks so we don't have to pay a premium at the fireworks, right? And you break the little thing inside, and it goes crunch, 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 and the stick starts glowing. It's giving off light energy. That's also an exothermic reaction. So when you see light given off, that indicates you've got an exothermic reaction. So here we're going to look at 4 different chemical reactions, and I want you to tell me what's the evidence that this is a chemical reaction. Mixing 2 solutions produces a temperature increase. It's exothermic. The evidence is, oh, that's not a good color, that the energy is given off. So actually, let's go review these. So an energy change is observed. An insoluble solid is produced. Permanent color change, a gas is produced. So those are the four things we're looking for. So that first one then is we're seeing an energy change. Pouring vinegar on baking soda gives foamy bubbles. Gas is produced. You can try that one at home. Gas produced. It's a chemical reaction between acetic acid and sodium hydrogen carbonate. Mixing 2 solutions produces insoluble particles. An insoluble solid is formed. I can't spell today. The spelling part of my brain is already on spring break. Mixing 2 colorless solutions gives a yellow solution. A color change. And it does need to be permanent. If you heat a piece of gold in a flame, you can heat it hot enough. Gold might not be a good choice. But you can heat metal to a temperature hot enough that it will glow, right? Depending on what metal is, when you let it cool down, it may be the same silvery, shiny metal that it was before. That type of a temperature color change is temporary, right? It goes back to its original color. Other types of metal, I know copper for sure, if you take a piece of shiny copper or a nice new shiny copper penny and you heat it in a flame, you can get it hot enough to glow, but when you take it out of the flame and let it cool down, it's not going to be shiny anymore because the copper reacts with oxygen in the air and forms a new compound. There you have a permanent color change, and that is a chemical reaction. Any questions?